Let me take you through the other one before I give you an exercise to do. Let me take you through the other one. Let me take you through the other one. Remember, the main objective for today's lesson, to prepare you for this coming test. The test will be written on the 17th of March. I want to prepare the grade 12 for this coming test. Thank you. Next one of the possible questions. Remember what I said earlier? I said, be aware. Check out for the proof of the theorems. That's why I showed you a proof of the Tankard theorem. I showed you the proof of that theorem. I did not do all other theorems. I only showed you one. Then I said there is also a possibility that there can be a question relating to the theorem. The theorem line joining the center of the circle to the midpoint of a chord is perpendicular to the chord. There can be a question based on that one. But now let's check this one. This one is a bit more general because it includes many other theorems. And in this case, let's go through it. O is the center of the circle. MPT is a tangent. MPT is a tangent. O is the center of the circle. So our task is determined with residence X, Y, and Z. So we need to apply our theorems here to solve this one. I'm telling you, definitely, it will be we can come across the proof of the theorem, followed by either the application of theorem 1, and then there must be calculations where we need to calculate before we can go to the questions that requires you to prove. Let's solve this one then. O is the center, that is key. MPT is a tangent. So if MPT is a tangent, the question states determine with residence X, Y, and Z. There we go. Determine with residence X, Y, and Z. From the theorem that we have just proven earlier on, check 64, check Z. 64, remember MPT is a tangent. PB is a chord. Therefore 64 is an angle between a tangent and a chord. And according to that theorem, to Tankard theorem, the angle between a tangent and a chord is equal angle in the alternate segment. That's why we say Z in this case. Z, if we have to solve, Z is equals to 64 degrees. Determine with a reason. Now you've got to provide a reason. Why do I say 64 degrees equals to Z? It's because of the Tankard theorem. Tankard theorem. That's how we determine Z. Now we've got the value of Z here. Remember, Z is now 64 degrees. Z is 64 degrees. It is always advisable to mark the angles that you have calculated. Indicate them on the diagram. Thank you. And next one. X is covered. Let's check at Y. Y. What is the relationship between Y and Z? Y is an angle at the center. Z is an angle on the circumference of the circle. So there is a theorem that states angle at the center is twice the angle at the circumference of the circle. So we say Y is equal to twice Z. Angle, the reason is angle at center, is equal to 2 times the angle on the circle, on the circumference of the circle. So we just have to substitute Y is equal to 2. We have already calculated Z. Z is equal to 64. You substitute Z by 64 degrees. Therefore, it means Y will be equal to 128 degrees. That will be the value of Y. Now we've got the value of Y here. The value of Y is 128 degrees. Thank you. Still have to determine X. How can you determine X? We've got different approaches. We've got different ways you can solve X using different approaches. Let's carry on. Thank you. Let's determine the value of X. Some will say, look at X and 64. Remember, O is the center. OP is therefore the radius. MPT is the tangent. So we know the theorem that states a tangent to the circle is perpendicular to the radius at the point of contact. A tangent to the circle is perpendicular to the radius at the point of contact. What does that mean? It means X plus 64 degrees must give you 90. X plus 64 degrees was 90. Tangent, because the tangent is always perpendicular to the radius. Tangent perpendicular to the radius. Then you just have to solve x. Therefore, x will be equal to 26 degrees. Because you've got to transpose 64 to the right, then you've got 90 minus 64, which will give you 26 degrees. That's how we solved that one. We applied theorems to calculate the sizes of angles. We applied theorems to calculate sizes of angles. So we are done with this one. Very much interesting. Very much interesting. So I'm going to take a break. I'm going to take a break and have a cup of water. But in the meantime, I'm going to leave you with an exercise to do. I'm going to leave you with an exercise to do. I think for you to complete the exercise, it will take you about 5 minutes. I'm going to give you 5 minutes to complete the following exercise. Thank you. Here is the exercise then. Here is the exercise. It reads, in the diagram below, two circles have a common tangent TAB. In the diagram below, two circles have a common tangent TAB. PT, here is TAB. PT, this PT is a tangent to the smaller circle. You can see you've got two circles there. This is a smaller circle and the bigger circle. So they've got this common tangent TAB. And also PT is a tangent to the smaller circle. PAQ, QRT, and AR are straight lines. Then let Q be equals to X. Here is Q is already marked with X. The first question states, name with reasons 3 other angles equal to X. You've got to apply your theorems and name 3 other angles equal to X. And then lastly, you then have to prove that APTR is a cyclic quad. While I'm having a water, I'm going to give you 5 minutes to finish off that one. And then I will take you through the solution there. Thank you. Welcome back. I hope you had 5 interesting 5 minutes whereby you were busy trying to solve this problem. Let me take you through the problem there. It reads, in the diagram below, two circles have a common tangent. It means TAB is a tangent to both circles. Then once you've got a tangent, once you see the word tangent, then 3 theorems must come to your mind. Tangent related to radius, tan cot, and tangents drawn from the same point outside the circle are equal in length. Those are the 3 theorems associated with tangents. Tangents drawn from the same point outside the circle are equal in length. Tan cot and tangent perpendicular to radius. But if you read it further, there is no indication of the center here. So we forget about the tangent perpendicular to radius theorem because you do not have the center. The center is not indicated. PT is also a tangent to the smaller circle. See, PT is also a tangent to the smaller circle. So it means already PT will be equals to AP according to that theorem, which states tangents drawn from the same point outside the circle are equal in length. It means TA will then be equals to TP. It is important immediately to indicate all the given information on the diagram. You mark them equal. This is equals to that one. It's PT is equals to AT. Those are the 2 tangents drawn from the same point outside the circle. And when you apply, you remember we've got different types of triangles. Even before you answer the questions, for different types of triangles. And you remember one of the triangles is an isosceles triangle. Look at triangle PAT. Triangle PAT therefore becomes an isosceles. Therefore, this angle P1 will also be equal to angle A3. We are just analyzing. We're just analyzing. Thank you. And remember, if we've got a chord, then we can apply the tan chord theorem. Tan chord can be applied in different ways. P1 can be equal to N. A6 will be equal to R2. A2 will be equal to X, and so forth. We haven't even started solving the problems, but I'm just trying to indicate to you how to apply the tan chord theorem. We are just analyzing the information. So Q is equal to X.